Hey guys, coming to you live from Gillette Stadium. If you're a Patriots fan, if you're another fan, I'm sorry. Um, I am Andy Thurai. I'm a field CTO at Splunk, and we want to talk about two things today. One is about our Splunk machine learning platform, how it helps with the fantasy live predictions we do, and two, we're going to have a big guest, Matthew Perry, big fan of him. Want to talk to him about if a man in the man versus machine, if man still wins, or machine is going to win in the future. So I have with me two of my colleagues, Yang and Ben. I'll let them introduce before we bring Matthew in. Yang?
Hi, it's nice to see everyone. My name is Yang. I am one of the machine learning architects here at Splunk, and I am responsible for building a lot of the cool stuff that we are going to be talking today alongside with my colleague, Ben.
Yeah, thanks, Yang. Hi, I'm Ben. Yeah, I've been building this with Yang, and we've been trying to create this fantasy football engine that we can use Splunk to leverage and show the power of machine learning. So we're excited to share it with you guys.
Now, the man of the hour, Matthew himself. Matthew, please go ahead and introduce yourself and tell us what you do.
Hi, thanks for having me. So Matthew Berry, my day job, I have a couple of different things that I do. I have a very lucky and blessed career. So currently I'm the senior fantasy football and sports betting analyst for NBC Sports. And so I'm a cast member of Football Night in America, which is the pregame show to Sunday Night Football. You guys watch all the games on Sunday Night Football on NBC. We've got a great one this week when the Lions visit the Chiefs. I also do a daily show for NBC Sports that airs on Peacock, YouTube, and as a podcast called Fantasy Football Happy Hour with Matthew Berry. We do that Monday through Friday. We're live at noon Eastern on YouTube and then available on demand, Peacock, YouTube, podcast, NBCSports.com, etc. I also do a Sunday morning show called Fantasy Football Pregame, which airs at 11 a.m. on YouTube and goes all the way up until 1 o'clock Eastern until kickoff. It's on YouTube and Peacock. So that's my day job. And then I'm also the founder of Fantasy Life, which is a fantasy football content, media, and gaming company that helps you win your bets, helps you win your leagues. We have a lot of tools and content to give analysis around that. You can go check it out 100% for free at fantasylife.com. So that's me. And I've been doing this for quite some time.
Oh my God, that's a lot of stuff. How do you sleep? Do you ever sleep? That's a lot of
I sleep after the Super Bowl. I'll sleep late February.
Agreed. Awesome. Great to have you on this webinar. So, we're going to talk a little bit about our machine learning platform and how do you do this fantasy prediction and then prediction engines, what you have built. So we'll have you at the back end of it come over, and then we have some tough questions for you. I hope you came prepared.
All right. Bring it on.
Go hang out in the virtual locker room, and we'll call you in a few to chat with you. See you then. So the Splunk combination of Splunk, AppD, Thousand Eyes, and Cisco provides AI power. What do I mean by that? Not only we help companies observe and make systems resilient in the vertical stack of application stack, but also on the network of wherever people are accessing from. If a network goes down, we'd be able to identify that fairly quickly. If an application stack goes down, it'll be able to identify quickly. And when you build the specialized models and deliver smaller models, we would be in a position to help you monitor the components of your AI application, whether it's a holistic application, or if you want to measure your components, such as your vector databases, such as your lang chains, or if your models are behaving properly, and how much of tokens you are consuming. Is your tokenization consumption is sufficient? Should you need to consume a different model for a better consumption? People don't realize that, especially when you start using different agentic model, agentic ops, your token efficiency and tokenization, token usage will go up sometimes by 10-fold, sometimes even by 100-fold. Are you prepared to meet the situation? Now, our approach to AI is slightly different than most of the other companies out there. One, we're going to be more of a domain-specific and Splunk-specific. I'll explain what that in a minute. We always have human in the loop, and we are open and extensible. We actually planning to donate all the models as to the open source, to the Hugging Face and other places. And more importantly, we build trustworthy AI. We are about observing the entire stack. We are about building applications that are trustworthy. Now, in order for AI environment to work faster, as I said, you got to secure AI, observe AI, and scale AI. The observing AI applications, as I mentioned, our Splunk platform helps you monitor not only the applications at a higher level, but also you'd be able to observe the components of the applications that are built, whether it's a vector database or LangChain or other components. In addition to that, we are also building what's called a specialized mission data lake using the Splunk platform, which will allow you to feed in all of your mission data. Particularly, we are connected with all of the Cisco systems now, whether it's a ThousandEye, Meraki, UCS, and so on and so forth. But eventually, in the future, we are also planning to build mission data from some of our competitors to the mission data platform, which will help you solve two problems. One, it'll help you avoid the partial visibility into systems. So if you're looking into IT systems, you'll have a holistic visibility of your systems. Two, it'll also help you build mission language models or AI models specialized for mission data in the future. One of the things we are betting on is the fact that the current LLMs, as we all know, is all trained using human-generated models. And we think the next frontier models will be trained using mission data. And we are building this lake to help companies build time series data and other anomaly detection and other data that will help you in your IT operations. And then I'll invite Yang and Ben back on camera, assuming you guys are still here. I want to talk about the machine prediction fantasy football platform.
Absolutely. All right, I see both of us on. Let me share my screen real quick because we are going to transition to a different set of slides. Can I just confirm from the team that we can see it?
Yep.
All right, amazing. Well, as Andy said, we are here to showcase the power of Splunk as a machine learning platform through the use of classical modeling. And classical modeling, this refers to the use of a set of lightweight, custom-trained, and secure machine learning algorithms that you can deploy to get more insight out of whether it be your company's data or fantasy football data. So let's put this in contrast. Whereas large language models are generalists by virtue of how they're trained, classical models are specialists by the same logic. It lets you deploy a model that is uniquely trained on your data and is therefore uniquely capable of tackling your objectives. So whether this be a common use case, such as anomaly detection or alert categorization, or an advanced use case, such as detecting fraud or predicting when a major alert is likely going to occur in the future, classical machine learning lets you tackle those things more efficiently and more securely, and it is also the method we chose to do fantasy football predictions.
Yeah, thanks, Yang. So we wanted to challenge ourselves a little bit into building something to showcase the power of machine learning capabilities Splunk has to offer. And we decided, fantasy football being both heavily stats driven and also completely unpredictable, it was a great place to start. So the problem is, as you can tell from my accent, I have limited knowledge of the NFL, and Yang actually knows even less than me because he's never actually seen a game. So getting the best data for this project proved to be a bit challenging. So I originally did some research, and I found that there was a website called Pro Football Reference, which had a huge amount of historic data on there. So from advanced statistics of players and teams to individual game scores, it looked great. On the website, it said that the data was provided by a company called SportsRadar. So we reached out to them to see what they can do. So SportsRadar has a ton of API endpoints that I was able to write very simple Python scripts to pull the data and send it to Splunk via a token called a HTTP event collector in a very, very short space of time. See, for me, it's one of the best things about Splunk is how easy it is to get the data in. And it doesn't matter how that data is structured. It is just so easy just to pull that across. Now, if I was pulling data on a regular basis and I wanted to automate this, we have frameworks and add-on builders that can help you do this. In fact, we have a whole website called Splunkbase devoted for this vendor-specific APIs. But for projects like this, you can basically spin up a free trial of Splunk, write a simple API call, and start it today and start bringing all the data in. So we started ingesting a number of data sources on everything from the player's performance, historic stats, team performance, trends, opponents, down to the type of turf and actually whether the teams are playing in. And because of the Splunk's capability as a data platform, we were able to easily correlate all of that together. So when we started this, we didn't know what specific data we needed to get the machine learning predictor working, but that's what's great about Splunk. We didn't need to. All we needed to do was get the relevant information for the subject we cared about, and then Splunk can do the rest. And furthermore, we're able to take advantage of the platform to easily enrich, pre-process, and normalize that data, making it ready for our machine learning models to operate on it. To help illustrate the process to details, I'm going to pass you on to Yang. Now, what he doesn't know about NFL, he makes up for on everything he knows about machine learning and AI. So I'll let him explain the machine learning part of the process.
Yeah, absolutely. So as Ben just said, everything begins with the data. So we will take, for example, let's just say any player, let's say Jalen Hurts, right? So as we said, we got ingested data about his past games, and our goal is to predict how many fantasy points he will score in the next game. So if we have information about week 1, we want to know exactly how he will do in week 2. So to do that, our first step is to realize that within our data and within all of your data, there are things that are good predictors for his score or for things you care about, and there are things that are bad predictors. So our first job is to reduce noise and identify and isolate what those good predictors are. So because Splunk has machine learning models available out of the box, what we can easily do is train a preliminary supervised model on this data, which takes a look at the data and extracts the best predictors for Jalen's score. We are then able to inspect the weight matrix of the model in Splunk and then rank each feature by its importance, basically saying, hey, how many, I don't know any of the stats, but how many like yards he ran or a certain stat A or B is more important than stat C. And we can get that feature ranked by importance. And by taking the top 10% of importance features, we have our relevant fields. So now that we know the data points that are the best predictors for whether Jalen Hurts will perform well or not, at this point, we can go ahead and do our prediction. But with Splunk and with the fact that Splunk is a unified data platform, we can do quite a bit more to help our model and get that edge that we need. Specifically, we can use Splunk to correlate data from different sources to give the model more context for how a player might perform. So in addition to player data, we can correlate data about the opponents they're playing against, as well as known environmental data, such as weather, turf, and whether they're playing a home or an away game. And despite these all being different data sources, having unique formats, and coming in just a little bit non-homogenized, Splunk is able to easily stitch all these data sources together out of the box, saving us a lot of time and effort. So where are we at now? So now we have our enriched data about our player, and we can begin fitting a model to predict his future performance. What we're going to do here is we are going to test a model's performance on historical data. We're going to measure the error as the average difference between the predicted fantasy score of his next game and the actual fantasy score of his next game. And not only can we do this with one algorithm in Splunk, we can do this with every single algorithm. Splunk helps us easily test this against everything that we have available out of the box, giving us our average error score for each model created, or we can even call this the average accuracy score. This way, we can understand how each model performs on this prediction job and pick the best one. So in our case, the best performing model is something called the random forest regressor, which is able to consistently predict fantasy scores within, on average, 5 points of a player's actual score. So now that we know our algorithm, we have our model, we have our confidence range, we can then apply our model to next week's DraftKings roster and generate our projected fantasy score with the peace of mind that any score it generates will likely be within 5 points of a player's performance in the next game. So just like that, we were able to leverage Splunk's out-of-the-box machine learning, search, and dashboarding capabilities and create something which can take a chaotic system like fantasy football and extract good insights and predictions from it. And we were able to do this in, I would say, only a couple weeks of work, fully on CPUs, and we didn't have to write one single line of code for the algorithm itself. But most importantly of all is this. Because we are able to measure exactly how accurate our model is, we are able to better understand exactly what role it should play within our fantasy football strategy. Just like how you would be able to know exactly what role a model should play in your data strategy. So while today, what this means is that we get to have a lot of fun making fantasy football drafts and talking about AI, at the end of the day, when you get back to your team and you have that conversation about large language models, about machine learning, about agentic AI, I want you to think about what we learned here today. I want you to think about how in a world of heavyweight problems and big promises, a data-first solution can give you a more reliable, measurable, and a more secure machine learning platform. So with that, I do want to turn it back over to, I believe I'm turning it back over to Andy and Matthew to discuss, launch some questions before we talk a little bit more about the actual guts of this project.
Let me ask you a question. Some of the prediction models, whether what you do or the ESPN and other guys do they all use AI in some capacity, especially you, because you've been doing this for a while now. Have you started using AI? Are you doing it by yourself?
Yeah, I'm doing, we use a little bit of it. To be honest with you, I am so busy between, the daily show I do, the 3 different shows I do on Sunday. I do a Sunday morning show, I do the Sunday night pregame show, and then I do a postgame show as well on Sunday Night Football. And so I'm so busy with that. I write an article, I do rankings. I no longer do my own projections. I don't have the time to do that. Over at fantasylife.com, we have a guy named Dwayne McFarland who's fantastic at it. And so I often use his projections. And so those are proprietary. He has a model. I think AI contributes a little bit to that, but a lot of it, he's been doing it for a long time. And so he uses, I think he uses AI to, in essence, bring in the information, but then it puts it through his own model and his own tweaks, right? The thing that, and I know we're getting here, but the interesting thing about AI is like, I heard you when you were interested in Yang, Andy, so Yang isn't a football fan and yet can compete really, really strongly in fantasy football just by looking at the data, just by looking at the numbers, by using AI models to help out.
Which is very unfair.
Right? Yes. But you know what? There's a nuance here as well. And this is why I think AI and the human element work so well together, because while AI can understand the numbers and the trends and what defense they're facing and how well they've done against zone versus man-to-man, and what do they do when they're blitzed and all the different data points that go into it, they may not know that this person's hurt. They may not know that, the wide receiver, made a crude joke at the quarterback's wife, and he's just not getting the ball this week. But we hear that, right? We may not know that, this player used to play for that team, right? And Rico Dowdle is going to play the Dallas Cowboys this week. He's the running back for the Carolina Panthers, and so they can tell me all the stats, but they don't know that Rico Dowdle was upset that the Cowboys, after a successful year last season, didn't re-sign him to a contract. And now he's at Carolina. And, candidly, he won't say this, but I think we all know this. You'd rather be a Dallas Cowboy than a Carolina Panther these days. So Rico Dowdle goes in there with a chip on its shoulder. And I don't know that AI can measure, pettiness and bitterness,
Well, I'll tell you what, I'm going to challenge you on that. Now, Yang
claims
that his engine is awesome. So he's going to show you his engine. He's going to show some of his numbers. And let's see if he can. Remember that, can you win against a 5th grader or whatever the show may be? Can you win against your engine? Let's see it.
Yeah.
Are you
I
smarter than
kind
a
of want
fifth
to
grader?
begin kind of with a question, actually, because I think what you just said just then was really, really interesting. So how our model learned, right, and how machines learn is through a process of identifying patterns in massive amounts of data. And we're able to achieve an average error of within 5 points of a player's future performance.
For sure.
So when you think about your process of evaluating fantasy football and making predictions, what do you look at? What is important to you? And more broadly, I want to hear your take on this. What do you think the role of that kind of human intuition has in making machines more accurate?
Yeah, I think it helps, and I think obviously when you have machine learning, it's more data points that you can put in there, right? And as they'll continue to grow, part of the problem is part of the challenge is trying to quantify the unpredictable, right? Trying to predict the unpredictable, right? Because no machine can predict when Amarian Hampton comes up, in the second quarter and he's got a high ankle sprain. And so, you're talking about a sport played by 22 people on a grass field with a leather ball that's in an oblong shape. Weird stuff happens. But to answer your question directly, like I think what AI does so well, to your point about coming within 5 points in terms of margin of error, which is so interesting, is that ultimately all fantasy football is trying to minimize risk. That's all it is. Again, it's an unpredictable game that we don't know how it's going to play out. So as we make those start-sit decisions, as we make those decisions of who to draft, who to drop, who to trade for, all you're trying to do is minimize risk. How can I, it's play the odds, like to use a blackjack example, right? The idea is that when you get 17, when you've got 17, you stay. Regardless of what the dealer is showing, you stay. Does it mean you're always going to win at 17? It doesn't. Sometimes the dealer has 16 and they pull a 5. It happens. But what you're doing is you're playing the odds. You're minimizing the risk. And the more often you stay on 17, you are more likely than not to win. And so that's all we're trying to do in fantasy football is put our teams and our players in the best position to win, to try to minimize that risk. And so I think taking it back to AI, to your point, like if you're like, hey, this is going to be within 5 points, that's minimizing risk. Now I'm on my range of outcomes. And what I've done is thanks to AI, I have now narrowed that risk. I now know my range of outcomes is within 5 points as opposed to 20, as opposed to 10, even as opposed to 7. Because fantasy football often, Andy, and you know this here in 4 leagues, it often comes down to one play, one player, 1 point, right? The margin of error, the razor thin margin between victory and defeat comes into play a lot more often than you think, because generally speaking, most people have played fantasy football for a long time. Most people know what they're doing.
Yeah. I think that's really interesting, actually, as well. When you were saying about the, certain players and certain positions that you would pick, because one of the biggest things, or one of the biggest challenges that me and Yang had, especially when we were actually picking the Splunk lineup, the lineup we were going to select, because obviously, as you're fully aware, on a platform like DraftKings, you have a very set cost that you can pick players. So one of the biggest things we had these predictions of the, within 5 points. But you can't have the best people. You can't just pick the people that you think are going to score the best, because you'll be over budget. You won't be able to select that in the lineup. So, and I'll get Yang to spring up the just show you the kind of our lineup and what we've predicted and what we've gone for. But in your experience, I guess, and what you've been doing, what would you weight position wise, or what would you see as the most important positions to kind of go for high points wise? Is there a particular method you go for?
Yeah, so it's a great question, and I think the answer is like, what game am I playing? So again, there's so many different forms of fantasy football. What you're talking about is DraftKings, and so DraftKings is, generally speaking, it is a salary cap. You have $50,000 of fake money to build your roster, and every player Patrick Mahomes is is a lot more expensive than Cooper Rush, who is the backup quarterback of the Ravens, who's going to start this Sunday, right? And so what you have to do is, how do you fit the best possible lineup under budget? Do you want to spend $9,000 Mahomes? Well, all right, then you're probably going cheap at running back, et cetera, et cetera. Compare that, and often in DraftKings, you're playing against 100,000 people, 50,000 people. You're in these large tournaments. Whereas in a season-long league where it's you and 11 other buddies, you're just playing head-to-head. You don't need to be the best team in the league. You literally just need to beat the player you're facing, right? And then there are other DFS-type daily fantasy sports. There are other type games where you're playing against the house, in essence. So the answer to what position is most important sort of depends on what your goal is. Are you trying to beat 50,000 other people, or are you trying to beat the person opposite you? And it also depends on what's the format. So in a single season, in a 12-person league where my roster only requires me to play one quarterback, that's a position that, is not that important, because there's 32 starting quarterbacks, 12 teams in the league. Only 12 teams are going to need, there's only 12 quarterbacks starting in any given week. So on the waiver wire, there's often a decent amount of availability. But if the league is a super flex league, and let's call it a 14-team super flex league, which means you can play two quarterbacks in a super flex league or a two quarterback league. Well, now you're telling me every single week, 28 starting quarterbacks are getting started, which leaves only 4, and people are going to hoard them on the bench. So now I'm drafting a quarterback in the first round because that's a scarce commodity. So it all depends on sort of scarcity and everything like that. What I would say about your model, when you're talking about, Ben, when you were talking about DraftKings specifically and how do we set our lineup because we can't get all the best players, to me the model is okay, what's the fantasy point per dollar? So the idea might be is that we think I'm making up numbers here, but we think Patrick Mahomes at $9,000 is a better player than Justin Herbert at $7,000. We think Mahomes is going to score more points this week than Justin Herbert. But if we divide it if we say we think Patrick Mahomes gets 22 points and Justin Herbert gets 20 and a half, you're like, oh, on a point per dollar basis, Justin Herbert is actually the better value, because that's the key to a DraftKings lineup, is maximizing that $50,000. How can you generate the most points under that budget constraint, right? And so that's the question you need to be training the model on, is not who's the best players, but who's the best player for the money. So I don't know that I've answered your question directly, but hopefully I have answered it, because the short answer to a long, I just answered it long, but the short answer is it's all context. There's not any one position that's more valuable than the other. It's all context in terms of the contest and the goal.
So
no, that's great.
There's actually a question in here, which is more of a Splunk platform related than to Matthew. Yang or Ben, do you guys want to answer that?
Yeah, of course. So I'm seeing the question here. It says, what makes Splunk's AI platform better than other AI platforms? Obviously, it's great for observability data. What makes it good for other kinds of data? It is, as you can see here, how we can ingest just about any kind of text and human readable data that is possible, right? We're not limited to a certain scope of information, which means whether we are training a model like we saw today to just predict roughly how well a player will do in the next game, or as Matthew suggested, trying to take that extra step, implement a full neural network driven by all the data, weighted by the most recent events and everything else to truly win a league and get that unorthodox pick, we are able to support that, because we're not just working with the most convenient data. We're working with all the data that you have that is at your disposal. And at the end of the day, when we are looking at these data-driven questions and data-driven platforms, measurability and diversity is key, and those are our strengths.
Awesome. Thanks, guys. Thank you, Matthew. Yeah, it's an honor speaking with you, man. Really, I mean, I followed you for many years, and I will continue to follow. And keep in mind, you told me I'm your +1 for the Super Bowl. Don't go back on it. I'm calling you up.
Okay. Yeah, no, definitely. And it definitely was me saying it, not an AI version of myself. Yeah. For sure. Well, listen, honestly, Andy, thank you so much. And thank you to Splunk for the opportunity to talk to all of you. I'm honored by it. And for somebody that works at an AI company saying, hey, I'm still going to follow you, even though you got Yang down the hall with his amazing model. I'm incredibly flattered by that, Andy. So thank you so much.
No, thanks. Awesome, man. I will keep in touch. And thank you, Yan and Ben. Yang and Ben, I'm sorry. And thank you, everyone, for coming today. So you will receive email instructions today on how to compete against Splunk Prediction. I hope you can win against our prediction engine. And this is in the Splunk FanDuel Fantasy League, by the way. The league will go through throughout the season, so you can predict against each other week, and you will win prizes for it. But the form has to be filled out today. Prizes will be given to anyone that beats the engine, and signed memorabilia by Matt. Oh, I should get one of that. We'll go to whoever comes in first. For more info on Splunk's AI capabilities, please follow up with your Splunk account team. Please feel free to follow me on LinkedIn or Twitter, which I barely use anymore. Thanks again, and good luck with the fantasy football. That's it. Thanks, Matthew. Thanks, Yang. Thanks, Ben.
Thank you, guys.
everyone.
Good luck this week.